Hello friend, you know that I is equal to mu r naught square. Mu here reduced mass. So mu is equal to m1 m2 divided by m1 plus m2. Here B is equal to h by 8 pi square IC in centimeter inverse. So mass is more, reduced mass is more, moment of inertia is more, rotation constant B is less. Mass is more, reduced mass is more, moment of inertia is more, rotational constant B is less. That is the significance of this equation. Now, isotope effect. If one of the atom in a heteronuclear diatomic molecules AB is substituted by the isotope of the same element with higher mass number A prime B, then the position of the absorption line in a rotational spectra of these two molecules will be different, and this phenomenon is called an isotope effect. For example, HCl and HCl, chlorine 35 and chlorine 37. Isotopically substituted molecules A prime B will have higher reduced mass than AB. You know, the bond length R naught is the same for both A prime B will have the higher moment of inertia than AB. Rotational constant is inversely proportional to the moment of inertia, and hence rotational constant of A prime B will be lower than that of AB. So rotational spectra of these two molecules are shown in the following figure. Isotope effect is very useful in the calculation of isotopic masses. So you can see here 2B, 4B, 6B, 8B, difference 2B, 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 AB molecules. Now after adding isotopes 2B prime, 4B prime, 6B prime, 8B prime, 2B, 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 AB molecules. What will happen here? The shifting, how it is shifted. So applications of microwave spectroscopy. Determine the moment of inertia I of the diatomic molecule. From the recorded absorption rotation spectra, the spacing between the consecutive line 2B is calculated. From this, I is calculated using formula. I is equal to h by 8 pi square BC, where h is equal to, Planck constant. Pi is equal to 3.14. B in centimeter. In meter inverse, you can change with the 1 centimeter is equal to 100 meter inverse. And C is equal to velocity of light, and I in the kg meter square. So the second important determination of bond length R naught for diatomic molecules. First, the moment of inertia for a given molecule is calculated from the recorded spectrum as stated above. Then the reduced mass mu of the molecule is calculated from the atomic masses using the formula. So mu is equal to m1 into m2 divided by m1 plus m2 in kg. Finally, the bond length is calculated by using the formula I is equal to mu r naught square. R naught square is equal to 1 by mu. R is not is equal to 1 by root over I by mu. Since the bond length are small distance, these are usually expressed in nanometer. 1 nanometer is 10 to the power 9 meter, or less frequently in angstrom. 1 angstrom is equal to 10 to the power 10 meter. Now, numerical on the microwave spectroscopy. While solving the numerical on microwave spectroscopy, given data should be transformed in SI unit to avoid confusion, and all the calculations should be carried out in SI system of unit. Students should remember the value of following constant and use these values in calculation. If these are not provided in questions paper, Planck constant, this velocity of light, this pi is equal to this 1 mu, So 1 by Na, 1 by that is the Avogadro number, you will get this kg. Now, for developing confidence, students should proceed as follows. Read the numerical very carefully with concentration and note down the given information. Write parameter or variable to be evaluated. Write the appropriate formula correctly. Substitute the value with the proper units. Work out the required arithmetic calculations and write the answer with proper units. For example, internuclear distance in HF molecule is 0.092 nanometer. Calculate the moment of inertia of HF molecules. So mH is equal to given 100 mu, mF given 19.00 mu, 1 mu is equal to this kg. So what is the solution? Give that R0 is equal to this, nanometer converted into meter, mH in mu, mF in mu, 1 mu is equal to this much kg, unit I value. So we know that I is equal to mu r square, mu is equal to m1 into m2, m1 plus m2 is equal to mh into mf, mh plus mf, 1 into 90 plus 1 plus 19, that is this mu. This is converted into 1 by in kg. So I is equal to mu r naught square. This calculation, this values is multiplied by this values, r naught square, then I is equal to 1.33 into 10 minus 47 kg meter square. Now the second example, the rotational spectrum of HF has line 41.9 t meter inverse apart. Calculate the moment of inertia and bond length in HF. Give mH is equal to 1 mu, mF is equal to 90 mu, C is equal to this much, H is equal to this much. So solution 2b is equal to this and b is equal to this. So I is equal to h by 8 pi square bc. You have all values, put it here. Then mu is equal to this values, mu converted into kg. So I is equal to mu r naught square. R naught square is equal to I by mu. Now r naught is equal to root over I by mu. You just put add the I values and mu values and do the bracket calculation. You will get this in meter. Now this meter is converted into nanometer, 0.092 nanometer. Now third examples, the rotational spectra of CO shown a series of equidistance line having a space 3.84235 cm inverse apart. Calculate the moment of inertia and bond length of CO. So 1 meter is equal to this centimeter, 1 meter inverse is equal to 10 to the power minus 2 centimeter inverse, or centimeter inverse is equal to 10 to the power 2 meter inverse. So carbon 12 mu, oxygen 16 mu. So 2b is equal to this centimeter inverse, meter inverse and meter inverse. So MC is equal to 12 mu, MO is equal to 16 mu, 1 mu is equal to this. So I is equal to what? R naught is equal to what? So we know that I is equal to h by 8 pi square BC. So I is equal to h by 4 pi 2bc. Now you can add all values, you will get this and convert it into kg. Now mu m1 into m2, m1 plus m2, mc into mo, mc plus mo, you will get this in mu converted into kg. Now I is equal to mu r naught square, or r naught square is equal to I by mu. So r naught is equal to you add all values, you will get in meter and finally in nanometer. Now the next example here, for ACL the frequency difference between successive absorptions line has been found to be 20.7 cm. Find the bond length for a Cl molecule in the rotational spectra. MH is equal to this, MCl is equal to this. Now solution is equal to 2b. or B is equal to 10.35 centimeter inverse, convert into meter. I is equal to h by 8 pi square BC. Now you add all values, you will get kg meter square. Reduced mass of HCl molecule is given by, you have to calculate in the mu, convert into kg, and then you calculate the R naught value, root over I by mu. Add the I values, mu values, you will get in the meter and finally in meter. Now the last example, example number 5. The microwave spectrum of HI molecule consists of a species of equidistance line with the spacing of 12.b centimeter inverse. Calculate the bond length for HI. MH is equal to 1 m, I is equal to 127 mm. Now 2b is equal to this centimeter, b is equal to this centimeter, converted into meter inverse. I is equal to h by 8 pi square bc. You add all values in kg meter square. The mu, you will get this mu converted into kg. So R naught square bond length 1 by mu is equal to this meter square converted into meter and converted into nanometer.